Hello everyone, welcome to In 5 Minutes. In this video we are going to see type 2C of making equation exact. So before this we saw type 2A and 2B. So in this two type, when the equation is not exact, then we used to check whether our given equation is of the form. So we used to check whether our given equation is of the form this. So if our equation can be represented in this form, then our integrating factor is given by 1 upon mx minus ny. In type 2b, we used to check whether our equation is homogeneous or not. If our equation is homogeneous, then the integrating factor is given by 1 upon mx plus ny. But in type 2c, we have another two types. If our equation is not exact and if we cannot represent our equation in either of this form, then we check for type 2c. In type 2c, we just check the partial derivative of m with respect to y minus partial derivative of n with respect to x upon n is equal to some function of x. Like we find the partial derivative of m and n, then we subtract, then we divide by n. If this whole value turns out to be a function of x, then the integrating factor is given by e raised to integration of f of x dx, where f of x is this value. Similarly, in this type, we subtract partial derivative of n with respect to x minus partial derivative of m with respect to y divided by m. In this case, it should be a function of y. Then integrating factor is given by e raised to integration of f of y dy. So as you can see, if either of these two, if our equation is not exact, then we check whether our equation is in this form or in this form. If our equation is not in this form, then we check for type 2c. In type 2c, we just subtract the partial derivative. When we subtract n from m, then we divide by n, and we subtract n, and when we subtract m from n, we divide by m. It's just that the negative of n is divided by n, negative of m is divided by m. If this is a function of x, then integrating factor is given by this, and if this is a function of y, then integrating factor is given by this. So after finding integrating factor, we multiply this by the given equation, and we again check for the partial derivative. The rest of the procedure remains the same. So now we are going to see the first problem on this type. So as you can see, this equation is of the form m dx plus n dy equal to 0. What is m? M is nothing but this 1 minus xy plus x square y square. What is n? N is nothing but this value, which is x cube y minus x square. Now what we are going to do? We are going to find the partial derivative of m with respect to x. Now we are going to find the partial derivative of m with respect to y. Here x will be constant. So derivative of 1 is 0 minus x is constant, so it will remain as it is, and derivative of y is 1. X square is constant, so it will remain as it is, and derivative of y square is nothing but 2y. If I rearrange this term, we will get partial derivative as minus x plus 2x square y. Similarly, if we take the partial derivative of n with respect to x, here y will be constant, so y is constant, so it will remain as it is, and derivative of x cube is 3x square minus derivative of x square is 2x. If we rearrange this term, we will get partial derivative of n as 3x square y minus 2x. So from these two equations, we can conclude that partial derivative of m with respect to y is not equal to the partial derivative of n with respect to x. So the given equation is not exact. So when the given equation is not exact, we will make it exact. So this equation, if you can see, it cannot be represented in our type 2a form. Okay, what is type 2a? Just we saw it should be a function of x comma y into y and so on. It cannot be a homogeneous equation because here the power is 2 and here the power is 4. So it is not a type 2b also. So now we are going to check for type 2c.